Welcome back to the deep dive. Today we are wading into what I can only describe as a quiet but really intense religious war in the tech industry.
That's a good way to put it. A religious war.
It really is. It's a battle between two very different philosophies of truth, and if you work in any kind of modern business, you have absolutely felt the tremors of this conflict, even if you didn't have a name for it.
It's a fundamental divide, for sure. It's the battle of the dashboard versus the survey. Or to put it in, I guess, more philosophical terms, the objective versus the subjective.
Right. And on one side, you have the hard data absolutists. These are the and look, I have definitely been one of them in my career, who live and die by system logs, tool chains, automated metrics, uptime reports. The philosophy is it's incredibly seductive. If the machine didn't record it, it didn't happen. If I can't query it in SQL, it's not a fact.
The subjective is suspect crowd. It's really the prevailing wind in engineering, isn't it? We want deterministic answers. We want a number.
Exactly. And then on the other side, you have the soft data advocates, the researchers, the sociologists of tech, the organizational psychologists. These are the people asking questions, running surveys and dealing with all these squishy things like feelings and burnout and culture.
And the assumption, usually, from that hard data side, is that the hard data is the gold standard. It's the bedrock. And the soft data is just fluff,
Yeah.
Or maybe it's a backup plan if your logging server crashes.
But the research we are unpacking today, and we're focusing specifically on the methodology behind these massive industry studies like the State of DevOps reports, is making a claim that, frankly, I found really hard to swallow at first.
Yeah, it challenges a lot of core beliefs.
It does. They are arguing that if you rely solely on your system data, on those objective hard numbers, you aren't just missing the full picture. You might be looking at a picture that is fundamentally wrong.
It's such a bold stance. But when you drill into the why, which is what we're going to do today, it's actually terrifyingly logical. We aren't just talking about missing context. We are talking about these huge structural blind spots where the machine simply cannot see reality.
So that is our mission today. We are going to look at the why. Why would a serious engineer, someone who loves code and logic, choose to use a survey when they have a perfectly good data warehouse available?
Right.
We're going to break down 5 specific superpowers of survey data that machine logs simply cannot replicate. And I want to be really clear before we start. We are not saying delete your Splunk instance.
No, please don't do that. Keep your dashboards. They are absolutely vital. But what we need to do is understand that the dashboard is a map, not the territory.
That's a great way of putting it.
And sometimes, that map has dragons on it that aren't real, or it shows a highway where there's actually a cliff. You need another source of information.
Okay, so let's jump into the first dimension. This is, on the surface, purely logistical, but it really sets the stage for everything else. The source material calls this the speed and scope advantage.
Right. And to really get this, you have to look at the scale of the research we are talking about. The State of DevOps reports are global studies. I mean, we are talking about data gathered from tens of thousands of respondents.
Just pause on that number for a second. Tens of thousands, that's not a small sample size.
It's enormous. And it's not just one company, which is key. It's representing thousands of different organizations. You've got banks in London, startups in Silicon Valley, retail giants in Tokyo, government agencies in Brazil. Every industry, every size, every tech stack imaginable.
So let's put ourselves in the shoes of a researcher. Your goal is to answer a seemingly simple question. How does software delivery performance compare across all these different industries? I'm the researcher. And I'm a hard data purist. I don't trust people's opinions because, people are biased. I want the truth. So I want to see their deployment logs. I want their Jira tickets. I want the timestamps on their GitHub commits.
Okay, so walk me through how you get that. Practically speaking, what's step one?
Well, I suppose I ask them for it. I draft a very polite email to the CTO of Bank of America and the CTO of a 10-person startup in a garage somewhere and say, hey, could you please send me your raw production logs?
And what happens next?
I get laughed at.
Yeah.
Or more likely, just ignored completely. Maybe a CISO sends me a threatening letter.
You get blocked. Immediate hard rejection. Think about what you're asking. You are asking 2,000 different chief information security officers to open up their firewalls and send you their raw, proprietary, incredibly sensitive production data.
I'm asking for the internal heartbeat of their business.
Exactly. It's a complete non-starter. You would need non-disclosure agreements signed by thousands of different legal departments, all with their own quirks and demands. You would need security clearances. We aren't talking about public financial data that you can scrape from Yahoo Finance.
No, this is the secret sauce.
It's the secret sauce. That process alone,
Yeah.
just legal wrangling, would take a decade if it ever happened at all. It's an impossible ask.
Okay, so there is a legal firewall. That's a big one. But let's play devil's advocate. Let's say I have a magic wand, I wave it, and every company's legal and security team magically agrees. Sure, here are our logs. We trust you implicitly.
Great. So now you've cleared the legal hurdle. Congratulations. You now enter what I like to call Excel hell, or maybe ETL hell, extract, transform, load. This is the technical barrier that I think most people massively underestimate because they just assume data is data.
Right, a timestamp is a timestamp, a log is a log.
If only. Company A uses Jira for tracking work. Company B uses Trello. Company C uses a home-brewed spreadsheet from 2005 that only runs on one guy's ancient laptop.
And that guy is on vacation for the next month.
Of course he is. And Company D uses a customized instance of ServiceNow that they've hacked to pieces so it doesn't even look like ServiceNow anymore. The formats are completely incompatible.
They're alien languages to each other.
Totally. The column headers are different. In one system, the column is called deploy time. In another, it's prod push. In a third, it's just end date. And what does that even mean?
And the data types.
Oh, the data types. One system logs time in UTC, another in local Pacific time, another in Unix epoch time, and just a giant string of integers. You would literally spend the next 10 years just trying to write the script to normalize all that data before you could run a single meaningful analysis.
And even if you did somehow normalize it, you still don't know the context behind it. A ticket in one company might represent a 2-hour task. In another company, a ticket might be a massive 6-month project.
Exactly. The granularity is all over the map. So in this scenario, the hard data is actually an impediment to knowledge. It's too heavy, too protected, too messy, and way too context dependent. It actively resists aggregation.
It's high-friction data. Now, let's contrast that with the survey approach. The source material mentions they gathered this massive global data set over a window of just 4 to 6 weeks.
4 to 6 weeks. Just think about that efficiency. It's staggering.
Because the survey it bypasses the firewall.
It bypasses the firewall, it bypasses the lawyers, and it bypasses the API integration nightmare. You don't need to integrate with their system. You don't need a lawyer to review a log file. You just send the link.
And the respondent, who is an expert in their own system, aggregates the reality in their head. They do the processing locally.
They are the API.
I like that. They're the human API.
They are the intelligence layer.
Yeah.
They look at their own reality, and they answer a standardized question. How often do you deploy code? They don't just send you the log. They send you the synthesis of the log. The answer.
It's like the difference between trying to wiretap every single house in America to see what they are watching on TV, which is, illegal and technically impossible, versus just sending out a Nielsen rating card.
That's a perfect analogy. And there's another nuance here about data cleaning. In data science, there's this old rule of thumb that you spend 80% of your time cleaning data and only 20% actually analyzing it.
Yeah.
With system data from thousands of diverse sources, it's more like 99.9% cleaning. You're just scrubbing dirt forever.
With a survey, though, because you design the questions, the data arrives pre-cleaned, doesn't it?
Exactly. You have defined the structure from day one. You set the drop-down menu. You set the Likert scale from 1 to 5. It is ready for analysis almost immediately.
So superpower number 1 is sheer velocity and reach. If you want to compare diverse groups across organizational boundaries, surveys are really the only viable option. You literally cannot do it with hard data.
Correct. Unless you happen to be the NSA, you can't get that data. And even they would struggle with all the different formats. But that leads us right into the second problem, which I think is even more insidious because it happens even inside a single company. Let's say you do get the system data. You've got the logs from all the teams in your own company. You still run into what I call the Tower of Babel problem.
This is the definitions issue.
It is. And
Yeah.
if you work in tech, you have absolutely lived this. You've sat in meetings where people are arguing for an hour, not about the data itself, but about what a single word means.
Oh, every week.
The source material uses the specific, perfect example of lead time versus cycle time. These are two critical metrics for measuring speed in software development.
Okay, let's define terms so we were all on the same page. How does the source, the state of DevOps research, Define them.
In that context, they are very, very specific. Lead time is defined as the time from code commit. So the moment the developer saves their work to the version control repository to when that code is successfully running in production.
Okay, so commit to deploy. That's the window.
Right. Cycle time, on the other hand, is often defined in the broader industry as the time from when work starts. So when the idea is first picked up from the backlog. It includes the coding time, the design time, all the meetings, everything.
So lead time is a subset of cycle time. Lead time is sort of the last mile of the delivery process.
In a rigorous definition, yes.
Yeah.
But here is the trap. Ask 5 different engineering managers at 5 different companies. Or forget that. Ask 5 different teams in the same company what lead time means to them.
I see exactly where this is going. One person says it's from the moment the ticket was created in Jira.
Another says it's from the moment the QA testing officially started. A third says it's from the moment the customer first asked for the feature 6 months ago.
So Team A puts up a slide and says, our lead time is 4 days. Then Team B puts up their slide and says, our lead time is 2 days. If you're a manager just scraping data from their project management tools, looking for a field called lead time, you assume Team B is twice as fast.
But Team A might be measuring from the idea phase, the very beginning, and Team B is measuring from the deploy phase, the very end.
So Team A might actually be way faster in reality, but because their definition is so much wider, they look slower on paper.
Precisely. You are comparing apples to oranges, but the dashboard labels them both fruit. You might fire a manager because their metrics look bad, when in reality they just have a more inclusive and honest definition of the term.
Where you might reward a team that is actually slow just because they define lead time as, the last 5 minutes before deployment.
It's a massive risk for decision-making. You're flying the plane based on an altimeter that might be measuring in feet, or it might be measuring in meters, or it might be measuring distance from the moon. You just don't know.
System data is trapped in its local context.
It speaks a local dialect. It has no idea that the team on the floor above uses the same word to mean something completely different.
So how does a survey fix this? Because aren't you still just asking them, what is your lead time? If I ask you that, won't you just give me your own broken definition back?
No, and that is the clever trick of good survey design. You don't ask them for the label, you ask them for the phenomenon.
Explain that distinction. That sounds really crucial.
You don't ask, what is your lead time? Because that just triggers the definition war we just talked about. You ask, on average, how long does it take to go from code commit to code successfully running in production?
You describe the thing itself. You paint the picture with the start and end points.
You force the definition. You create a standardized Rosetta Stone for your data. Doesn't matter if they call it lead time, cycle time, or Fred's fun time internally. It doesn't matter what the column header is in their Jira instance. You are asking them to look at a specific bounded reality code commit to production and report on that.
So every single person who answers is answering the exact same question based on the exact same boundaries.
Exactly. You have normalized the data at the point of collection, not after the fact. You have bypassed the local dialect and created a universal language for your study.
And you can't do that with system data because you can't force a database to rename its columns or change its timestamp logic just for your study.
But you can force a human to pause and consider a very specific question.
That is really powerful. It's like the survey acts as a translator that standardizes everything before it even enters your dataset.
It creates a shared language where none existed. And without that shared language, any comparison you do between teams or companies is deeply suspect.
Okay, so we have speed and scope, and we have standardization of definitions. But this next one, this is where the research really started to challenge my worldview. It's a story from IBM, and it basically destroys the idea that if the logs are green, everything is fine.
The IBM box story. This is such a classic example of the limits of component monitoring.
Set the scene for us. This is back in the day, right? Big enterprise hardware.
Yes, this is a story from one of the authors of the source material. They were working as a performance engineer at IBM. We're talking about big iron. Enterprise disk storage systems.
So these aren't the little hard drives you put in your PC. These are refrigerator-sized beasts that live in a data center.
Exactly. Massive arrays costing hundreds of thousands or even millions of dollars. The stakes for performance are incredibly high. And this being IBM and these being performance engineers, they were thorough. They instrumented everything.
They had sensors on everything.
Everywhere. They measure disk seek times, write latency, cache hit rates, RAID controller rebuild speeds, bus saturation. They had sensors on every single internal component of this machine. If an electron moved inside that box, they knew about it.
So they had the ultimate dashboard.
The perfect dashboard. And according to that dashboard, the box was flying. It was a masterpiece of engineering. Green lights across the board, optimal performance metrics. The throughput was incredible.
There's always a but.
But the customers kept calling tech support, and they were furious. They all said the same thing. The storage system was slow.
Oh, I can just imagine the engineering meeting. The engineers are looking at their beautiful, perfect green dashboard and then looking at the support ticket.
And the initial reaction is almost always the same. The customer is crazy.
The customer's holding it wrong. Or it's user error.
The customer is lying. That's a really common defensive mechanism. The logs say 20 milliseconds response time. The customer says it feels sluggish. Clearly, the customer is just trying to get a discount on their service level agreement.
We've all been there. It works on my machine. It's the first line of defense.
Exactly. They dismiss the subjective human feedback because the objective machine data offered a conflicting and much more flattering truth. They trusted the machine over the human.
But the reports kept coming in.
They kept coming, and they had a pattern. It wasn't just random noise. It was consistent feedback from multiple customers. So the team finally had to do what engineers hate to do. Stop looking at the dashboard and go investigate this situation in the real world.
And what did they find? Was the machine actually slow? Was there a bug in the monitoring?
And here's the twist. The box was fast. The engineers were completely right about the machine's internals. The disks were spinning at the right speed. The cache was working. The monitoring was correct.
What was the problem?
The interface was the problem.
The interface, the software to manage it.
Exactly. The management software. The layer that the system administrator had to click through to allocate storage, to set up the drives, to run diagnostics. It was clunky, it was confusing, and it was painfully slow to respond to clicks. The way the customers were interacting with the system introduced a massive bottleneck into their workflow.
So the engine was revving perfectly, but the steering wheel was locked, or the gas pedal was stuck under the floor mat.
That's a perfect analogy. The system data measures the component. The survey, or in this case, direct customer feedback, measures the interaction with the component.
That's a crucial distinction. The sensors were all inside the box, but the problem was happening outside the box, where the human actually touches the machine.
System data stops at the API. It stops at the screen. It cannot cross the air gap to the human being sitting in the chair. It can't measure frustration. It can't measure confusion. It can only measure execution time.
So the log says task completed in 0.1 seconds. But it took the user 10 minutes of confused clicking and searching through menus to find the button to even start the task.
Precisely. The system sees 0.1 seconds of work. The user experiences 10 minutes and 0.1 seconds of pain. The system says fast. The user says slow. And who is right?
The user is right, because for the business, the user's reality is the only one that actually matters. If they can't use the product, it doesn't matter how fast it is.
Exactly. If they had ignored that soft data, if they had just kept pointing at the green dashboard, they would have had a technically perfect product that failed in the market. You need that subjective feedback to contextualize the objective metrics. You need to know if the driver's terrified, not just if the engine is running at optimal RPMs.
It's the human in the loop problem. You can't debug the human with a system log.
You can't. You have to actually ask them.
This leads us directly into another flavor of blindness. The IBM story is about the interface, but there is also the issue of what the system simply cannot see because it doesn't exist in the digital record yet. The source calls this the void.
This is a really profound philosophical point about data. We tend to think that data represents the whole world, but system data is an ontology of what is. It is very, very bad at measuring what isn't.
The example they give is version control, which seems simple enough. Every modern dev team uses version control, something like Git. So you want to know if a development team is using version control properly.
Right, so the hard data approach is query the GitHub API, count the files, count the repositories, check the commit history. It's all there in the logs.
And if you see lots of files and lots of repos and frequent commits, you conclude, yes, this team uses version control. Gold star for them.
Seems logical, right? But the system cannot count the files that were never checked in.
Oh, right. The dark matter, the stuff that's invisible to the system.
The system has no way of knowing that 50% of the actual work is sitting on a developer's desktop in an untitled folder, or on a shared network drive, or being emailed back and forth in a zip file labeled Final v2 real finalesware.zip.
I've definitely lived that life, especially in older companies or teams that are under pressure. You have the official repository, and then you have the real work happening in the shadows because it's faster.
We all have. This system only knows what has been submitted to the system. And this creates a very dangerous false sense of security. You look at the repo and think, great, we have 100% of our code under version control. But you might actually have 20% coverage. The rest is invisible, undocumented, and at risk.
So how does a human solve this? Why is a survey better here?
Because a human has full stack visibility of their own environment. A developer can look at the repo, then look at their desktop, look at the shared drive, and honestly answer the question, yeah, you know what, we're only checking in the final builds. All the work in progress stuff is just floating around in the ether.
A human can report on the absence of data.
That is the key insight. Humans are the only sensors capable of reporting on what is missing from the digital record. If you want to know what percentage of our production artifacts are not in the version control system, you cannot ask the system. It doesn't know what it doesn't know. You have to ask the people.
This feels like it applies to so many things. Shadow IT is the big one that comes to mind.
Huge. If you ask your IT asset management system, how many servers do we have? It will dutifully list the ones it knows about. It will not and cannot list the AWS instance that a developer spun up with their personal credit card because the official procurement process was going to take 6 weeks.
And that rogue AWS instance is probably the one with the biggest security hole.
Of course it is. It's unpatched, unmonitored, and completely invisible to the hard data systems that are supposed to be protecting the company.
So you survey the developers. On a scale of 1 to 5, how often do you use cloud resources not managed by IT?
And suddenly the lights turn on in that dark room. You find the invisible infrastructure. You find the dark matter of the organization that poses a huge risk.
Okay, so we have established that surveys can see things the logs can't. They see the context, they see the definitions, they see the interactions, and they see the missing data. But we have to address the elephant in the room, the trust factor.
The skepticism.
But people lie. Exactly. The source material has this great little thought experiment. They ask 3 questions to audiences of engineers, and I want to try this on you, and on you, the listener, right now.
Let's do it. I'll play the part of the skeptical engineer.
Perfect. Question 1. Do you trust survey data?
No. Of course not. People lie. It's subjective. It's squishy. Human memory is flawed. It's not real data.
Right. That's the standard answer. We are trained to doubt it. Okay. Question 2. Do you trust system logs?
And here, all the heads in the room nod. Yes, absolutely. Machines don't lie. It's objective. It's binary. It's math. It's the truth.
And then you spring the trap. Question 3. Have you ever seen bad data in a system log?
And every single hand in the room goes up. Every time.
It is such a massive contradiction. We say we trust the machine unconditionally, but we all know from painful personal experience that the machine gives us garbage all the time.
We have all spent hours, days, even debugging a log file that was reporting the wrong timestamp because of a time zone bug, or a metric that was calculating the average incorrectly, or a sensor that was just stuck on 0 for a week, or a database that silently dropped a table.
The source brings up the movie Office Space, which is just the perfect cultural touchstone for this.
It's the ultimate documentary on software engineering culture.
For those who haven't seen it, and you really should, it's cultural homework. But the plot hinges on a piece of malicious code. They write a script to steal fractions of a penny from every single bank transaction. The old rounding error trick.
They're just shaving off the subsend amounts that usually get discarded and diverting them to a separate account.
And the financial reports, the system data, look perfect. The books balance to the penny. The dashboard is completely green. But the reality is that money is actively being stolen. The data is a lie because the code creating the data was intentionally manipulated.
The system data is only as good as the logic that generates it. Garbage in, garbage out. Or in this case, malicious logic in, fraudulent data out.
So let's analyze the vulnerability here. Why is system data so fragile?
Because it typically has a single point of failure. It only takes one person, a developer making an honest mistake, or a bad actor with root access, to corrupt the entire data set from that point forward.
Right.
If I change the logic in the logging script, every single log entry from that point on is wrong. The error propagates globally and silently.
It is highly leveraged. One small error creates infinite bad data points.
Exactly. If I mess up the timestamp conversion in the code, all the timestamps are wrong, not just some of them. The whole system is compromised.
Now compare that to a survey, specifically the kind of large-scale survey this source talks about. They had something like 23,000 respondents in one of their reports.
So imagine you want to hack the results of that survey. You're a disgruntled employee, and you want to make it look like the industry is deploying way faster than it really is.
I want to skew the data. How do I do it?
Well, you have a massive coordination problem on your hands. To meaningfully skew the results of a survey with 23,000 people, you would need hundreds, maybe thousands of people to all conspire together. They would all have to agree to lie.
And not just lie, but lie in the same way, in the same direction.
Right. They would have to agree on which lie to tell. Okay, everyone, on the count of 3, let's all say we deploy daily instead of weekly. And they would have to agree on exactly how to answer the specific questions to push the data in the same direction without looking like they're just making stuff up.
And trying to coordinate that without anyone finding out. In the age of social media and Slack, it's impossible. Someone would tweet about it. Hey, anyone else in on the great DevOps survey hoax?
It is statistically resilient. If one person lies on a survey, it's just noise. It washes out on the average. If one person hacks a log file, it's a catastrophe for the data's integrity. So, and this is the really counterintuitive part, large-scale anonymous surveys are actually more secure against bad actors than system logs are.
That blows my mind a little bit. We think of subjective as untrustworthy, but when you get enough of it, in aggregate, it is actually incredibly stable and robust.
It's the law of large numbers in action. The random noise cancels itself out, and the true signal remains.
But what about unintentional bias? People might not be lying, but they might just be biased. You know, they might think they're better than they actually are, the above-average driver effect.
That's a very fair concern. And this is where the methodology gets really interesting and, frankly, very clever. The source mentions they use latent constructs.
Okay, let's get technical for a second. Break that down for us. Latent constructs. It sounds like psychobabble?
It does sound like it, but it's actually a cornerstone of rigorous psychometrics. It's the same science used in clinical psychology to diagnose things like depression or anxiety. A construct is a concept you can't measure directly with a single question.
Like burnout. You can't just ask, are you burnt out, and get a reliable number.
Exactly. You can't stick a thermometer in someone to measure burnout. There is no burnout meter. It's too complex and subjective.
So how do you measure it?
You ask multiple related questions that surround the topic. You triangulate it. Instead of asking, are you burnt out, which is a very loaded question that people might answer defensively, you ask a cluster of questions. In the last month, how often have you felt emotionally drained from your work? How often have you felt cynical about your contributions? How often have you felt less effective than usual at your job?
I see. You come at the same idea from different angles.
Precisely. And here is the cool math part. If you're answering honestly, your answers to those 3 questions should correlate pretty strongly. If you say you are constantly drained and cynical, you probably also feel ineffective.
They all hang together logically.
But if you're lying, or if you're just clicking random buttons to get through the survey, or if you're trying to game the system to look good, it is really, really hard to keep your story straight across all those different angles without the math showing that your answers are inconsistent.
So the statistical analysis can actually catch the fakers.
Yes. Statistical tests, things like Cronbach's alpha or factor analysis, can check if the questions are all measuring the same underlying thing. If the answers don't align, the researchers can flag that respondent's data as unreliable and throw it out.
So there's a science to catching the liars and the biased responders. It's not just taking their word for it.
Absolutely not. It's a mature scientific discipline. You can weed out the bias mathematically. It's much harder to weed out a root-level hack in a production database.
This brings us to the final superpower. And this one is, for me, the big one. There are some things that simply do not have a log file, period. There's no machine data to even argue about.
The intangibles.
Culture, feelings, perception.
We all know that saying, culture eats strategy for breakfast. We know intuitively that a toxic team will kill a product faster than bad code. We know that if people hate their boss or are afraid to speak up, they won't do good work.
But there is no culture.log file on your server. You can't run a SQL query to measure morale.
You can't. It doesn't exist in the machine. It lives in the space between people.
But managers try to fake it, right? The source talks about this as the proxy trap. We try to use hard numbers to guess at culture because we are scared of surveys. We want a number we can put on a PowerPoint slide.
And the classic proxy, the one everyone uses, is retention or its inverse, turnover. The logic goes, if people are quitting, our culture must be bad. If people are staying, our culture must be good.
Which sounds logical on the surface. I mean, high turnover usually does signal a problem. If everyone is fleeing the building, something is probably wrong.
It sounds logical, but it falls apart the second you look at real human behavior. The source deconstructs this beautifully with a few scenarios.
Let's run through them. Scenario A. Someone quits. Is it a culture problem?
Maybe. Or maybe they got a 50% pay raise from a competitor. That's not a culture problem, that's a market compensation problem. Or maybe their spouse got a great job in a different city and they have to move. That is a life event, not a toxic workplace.
So turnover data is incredibly noisy. It mixes good quits and bad quits and neutral quits all into one scary number.
It is extremely noisy. But here is the real paradox. Let's call it Scenario C. Imagine a manager who is incredible, a fantastic, supportive mentor. They have an employee who has outgrown their role. This person is a star, but there is no promotion available for them at the current company.
They've hit the ceiling.
The manager sits down with them and says, "Look, you are amazing. You need to go somewhere that can really challenge you. I will help you write your resume. I will make calls to my network for you."
This is the happy lever.
The employee leaves to go on to a bigger and better role. They love their manager, they love the company, they tell everyone it's the best job they ever had, but they leave.
And the turnover statistic on the manager's dashboard goes up.
The dashboard turns red. It says retention failure. But the culture was actually perfect. It was supportive and human-centric. The metric says failure, but the reality was success.
That is tragic, actually. If you punish managers for turnover, you might be punishing the very best ones who actually care about their people's long-term careers.
And conversely, you end up rewarding the bad ones. Look at Scenario D, the gaming the system scenario. A bad manager knows they are being measured on retention. So when someone on their team wants to transfer to another department because they can't stand the manager blocks the transfer. "No, you can't leave. You're too critical to this project right now."
Or they make their employees' life so miserable that they quit, but they find a way to categorize it as a firing or a layoff so it doesn't count against their retention quota.
Right. Managed attrition. The retention number stays high. The metric on the slide looks green. But the employee is miserable and the culture is absolutely toxic.
So you can game the numbers, you cannot game the actual feeling.
The only solution is to ask. If you want to know if people feel psychologically safe, if they feel encouraged to share new ideas, if they feel they can make a mistake without being punished, if they're burned out, you have to ask them directly. There is no proxy. You cannot infer psychological safety from GitHub commits. You cannot infer trust from uptime logs.
And the source emphasizes that this isn't just HR fluff. This isn't just about being nice for the sake of it.
No, not at all. This is hard-nosed business strategy. They reference the famous Google study, Project Aristotle. Google studied hundreds of their own internal teams to find out what made the best teams win. They looked at everything: skills, seniority, education, personality types.
And the answer wasn't number of PhDs or average years of experience.
No. The number one predictor of high performance, of making money and shipping great product, was psychological safety. The shared belief that you won't be punished or humiliated for speaking up with ideas, questions, concerns, or mistakes.
So if you aren't measuring that because it feels soft, you are ignoring the single most important lever you have for organizational success.
It is a massive business error to ignore feelings. It's an operational failure. You are essentially driving the car while ignoring the engine temperature gauge because you think thermometers are too subjective. It's madness.
So let's bring this all together. We started with this idea that hard data is king and surveys are just for, opinions, but we have completely inverted that premise.
We really have. Let's just look at the scorecard we've built over this conversation. First, surveys allow you to move at a speed and scope that system data can't even dream of weeks instead of years to get global insights.
Right. Second, surveys create that Rosetta Stone that forces standardized definitions across chaotic teams, solving the whole Tower of Babel issue.
Then third, surveys capture the interaction at the interface, the IBM box problem, where the logs say everything is green, but the user says it's broken.
Fourth, surveys can see the dark matter, all the important work that isn't even in the system, like the files on the desktop or all the shadow IT infrastructure.
And finally, and maybe most surprisingly, large-scale surveys are statistically robust and resilient against bad actors in a way that fragile, single-point-of-failure log files just aren't.
It is a pretty damning case against relying only on the dashboard.
And again, to be clear, keep the dashboard, monitor your CPU usage, know your disk space. You need that information for the health of the machine. But you have to recognize that the dashboard is limited. It sees the machine, it doesn't see the work, and it doesn't see the people doing the work.
It brings me to this final thought. We spend millions, sometimes tens of millions of dollars, instrumenting our servers. We install these complex agents like New Relic, Datadog, Splunk. We want to know every time a CPU spikes or a disk fills up. We have pagers that will wake us up at 3 in the morning if a server so much as sneezes.
We obsess over the health of the
We
silicon.
do. But the most expensive, most complex, and most vital part of our entire system is the people. It is the engineers, the designers, the product managers. They cost the most by far, and they are the ones who actually create all the value.
And yet, we are so hesitant to instrument them. We're afraid to ask them how they are functioning. We often treat their feedback as noise, as an inconvenience. We prefer the comfortable, but often false, illusion of the dashboard.
Maybe we need to stop viewing subjective data as lesser. Maybe the subjective truth of the human in the loop is actually the most objective truth we have about how work really gets done in our organizations.
I would argue that until you ask the question, you don't really know what is happening in your company. You just know what is happening in your servers. And those are two very, very different things.
That is a powerful place to leave it. If you are listening to this, maybe it is time to draft that survey. Don't be afraid of the soft data. It might just be the hardest, most real data you have. Thanks for diving in with us.
See you next time.